In chapter 3, we focused on uh, arranging the data to display tendencies. Now, as we prepare, to test data, first, there is a need to review probability. Okay, so what is probability? Well, you see it all the time. That is the chance of an event happening. COVID epidemic has caused our media of the trends to contract. The new strains of COVID using percents. Changes to the community. So if the strain is high, then the percentiles are greater than 70. If it's medium, then the percents are between 40 and 70. And if it's almost non-existent or low, it is between 0 and 40. So they'll tell you we are in a high risk, a low risk, or what have you. And what they're implying is the probability. And the probability changes with the amount of exposure we have to other people or environments. So probability plays a big hand in giving us a clue of the trends, the percentile chance of occurring. All right. So another knowledge of probability is if a lady is pregnant with a single birth, then there's a 50-50 chance that it's a boy or a girl. That's the only two options on gender being produced by pregnancy. So these conditions give us an idea of the event occurring, and how much strength it has is what we'll measure in statistics. degree of confidence in the sample evaluated. We already know from the previous section, the bell curve has 100% of all of the data, and therefore we can use a percentile to find that particular data and the strength of that particular item. So we've already started understanding the expansion of data being in the bell curve to percentiles of data in it. And we've studied the rule of thumb. It's called the empirical rule of 68%, 95%, 99.7% of the data within the bell curve. So, so this kind of action gives us a pause to make sure we understand its probability. So we're going to take a little side road on this basic concept of probability. So what is the role of probability? It's the arithmetic proportion of the data. Well, actually, I should say it like this. The desired outcome knowing the number of outcomes total outcomes and the number of desired outcomes. So the role is evaluating. Strength of an event. So will you get COVID or not? Well, right now we're at a particular level, and we're always going to be conscious of careful response. So this is the formula. And it is the number of times A occurred over the number of times the procedure was repeated. In this case, it's the cardinality of the event you want over the cardinality of the sample space. And again, we get back into the sample space, which we learned in a prior section. So I've typed this out so that we can advance a little bit quicker. Now remember, you can always pause if you're writing notes. So we're talking basic vocabulary so we can communicate with one another on what is expected. An event is any collection of results or outcomes of a procedure. So this is the N. A simple event is an outcome or an event that cannot be further broken down into simpler components. That's a little sticky. All it means is that when we're doing statistics, a simple event is usually yes, no, or positive, negative. Those type of things are simple events. Three approaches to finding probability. And this is where we look at theoretical, experimental, um, and subjective. So these general terms are now in statistics are said to be relative frequency approximations of probability. Relative frequencies. Now that's what we studied way back in chapter 2. So relative frequency is the number that we get from any class that we had. And in this case, it's the number of times A occurred over the number of times the procedure was repeated. So here we're talking about mainly an experiment. Experiment. And then we're looking at the um, classical classical approach to probability. The number of way A's occur over the number of different simple events. And this is more observational. So in this case, we're saying we know what we're studying. We're studying how many times a boy is born over how many total number of births were given in a hospital. Those are observational or a classical approach. And then subjective. And subjective is more a feeling of the event being studied. All right. So in a pregnancy, uh, if the woman has it is a wives' tale that if her belly is like a basketball, then her baby is a boy. Uh, if her belly is low, lower, and less pronounced, well, now that's an old wives' tale. Is it true? Well, sometimes it is, and sometimes it's not. And again, we get that 50-50%. Well, I have a little diagram here to help you see what we're talking about. In this case, we're saying impossible. That means not going to happen if we have a zero. Unlikely is any portion between 0 and 1, 0.5, which is low. And then if we have 50-50, well, 50-50, which is 0.5, because it's in a decimal presentation, is equal chance of happening or not happening. And then likely is where that zone is. The beginning of likely infer a strong opportunity of the desired event happening. Statistics, it has to do with the number of data. So it says we've got a strong indicator here. A strong indicator is going to happen. And of course, the one is 100% and a certainty that it'll happen. A certainty. So there you have a small breakdown. So what did we, and we understand that percents or statistics starts as a value between 0 and 1 inclusive. All right. In statistics, we can get to 0.00008 chances of occurring, which means 0. Okay, and then we can get all the way to 0.999888888, which is close to 100%, which is a certainty. And likely is the word we use. Unlikely is what we use if it's a little bit larger than 0. Unlikely. So there you have it. All right. So now what we want to do is the notations of probability. P denotes probability, a capital P and a description implies probability. ABC denotes specific events, ABC. So I can have the probability of A or the probability of B, and those reflect the samples of what we're going to be doing. The P of A denotes the probability of event A occurring. The value of probability is between 0 and 1 inclusive. So now remember this part right here. So we're talking a decimal between a 0 and 1 inclusive, nothing larger. Well, which of the following cannot be probabilities? Well, we notice that it cannot be negative. It cannot greater than 1. So let's look at what we have here. What could not be? Well, this guy right here is negative. So it is not a probability. 5/3 is is greater than 1, because if we do the math on it, it is 1 and 2/3. So therefore, not a probability. 3/5 is good. It is called 3/5 is a value less than 1. So that one's good. The square root of 2 is interesting. The square root of 2 is an irrational number, and it is greater than 1. So therefore, this is not a probability. 1 and 0 are in the domain, and negative, 1 and 2/10 is greater than 1. This is greater than 1. This is greater than 1, and that is negative. So those are the conditions to get us prepared for knowing what is a probability and what is not. All right, so as we're doing the homework, you will know that the instances where you've made some kind of construction error. Never anything that is difficult. So here we're talking about the complement of an event. And a complement is when all the outcomes in the event A does not occur. And it uses a bar. So this is what I'm going to write for you. And hopefully it makes more sense. Now remember, the textbook uses precise information that sometimes leaves us in a want condition. So here we have, by placing a bar, this is the bar, above the identifier of an event implies the not desired event occurring. So what does this tell us? It says that 1 minus the probability of the event is the not of the event. So in simpler terms, if I have the probability of A equal to 0.53, then the probability of not the A event occurring is 1 minus the 0.53. So then we have the probability of not the event being 0.47. So what does this tell us between this and this? That the sum of the P of A plus the P of not A is 1. So let's test that. So if I have the P of A is 53 and the P of not A, I'm sorry, you need to see the bar, 47, I do get 1, and that is true. So the complement gives us an idea of how to deal with analyzing the opposite of event A in an easier form. Okay, so let's look at some examples here, and we'll make sure we get the gist of this lesson. So, let A denote the event of placing a dollar straight bet on a certain lottery and winning. So you're winning. Suppose that for the particular lottery, there are 5,600 different ways that you can select 4 digits. So the cardinality of our sample is 5,600 different ways to select the 4 digits of this lottery with repetition allowed. That means that it is independent. Each number is independent. Uh, and only one of those 4 digits numbers will be the winner. What is the value of P of A? What is the value of P not A? All right. So we have only one winning number set. And that means that the order of that winning number is precise. And we only have 5,600 ways the number set that they're using should occur. Again, with that order specific. So what is the value of the probability of A? So the probability of A is the desired event over the total number of events. So that gives us one winning selection of numbers over the total number of selection numbers. All right. And then we do the calculator because we want a decimal value. So here we go. I'm going to get my calculator out. I'm sorry, I didn't have it up. And you can see it's from our last section. So I'm on my home screen because it's done on the home screen. So I'm going to enter the 1 because a fraction is undone division divided by the 5600. And I get this. Now, the reason this is important is because it is not a 1.7857 blah, blah, blah. It is an e to the negative 4. So this means, this guy right here means decimal moves 4 places to the left. In other words, it's 10 times, 10 to the, I'm sorry, I know better than that. Sometimes the instructor loses track of things. Okay. Uh, 10 to the negative 4. That's what you consider e to the 4. So we want to first see this value. So what I'm going to do now is round to 4 decimals. Well, I did 3 decimals. That's good enough. All right, because I need really. So let me erase that. I need 4. 5. I'm going to do 5. All right. So if I did it manually, I would go 1, 2, 3, 4. There I would have that number. But if I did it on the calculator, we said it was 10 to the negative 4. So let's do that. So I'm going to put the number 1 decimal, and I'm going to enter what I wrote. 78571 times 10, and the negative sign, I'm going to do up caret negative 4. And oops, it gave it to me because I have too many digits. So let me reduce the digits. 7, and I'm going to just do 8, 5. It's so many decimal places that, nope, it won't do it. So you're going to have to do it manually and know that it's moving that direction. So we have the value of this. This number right here. And the computer will tell you how many decimal places to put your probability. Well, we needed a construction that is representative of the data. So now what we want is the probability of not A. And we know that's 1 minus the probability of the desired event happening. So let's do that. All right. So now I'm going to have the probability of not A equal to 1 minus decimal 0.000 3 zeros 1 8. So then the probability of the event not occurring is very strong, right? 99982. Because 0.0018 plus 0.99982 equals 1, the entire probability factor, the certainty of it occurring. All right. Now we're talking about this example here. And this one is a sample of the probability of a object, of an object. So what we're talking here is a single die. And so in a die, have 6 sides. And the numbers are like this guy is 1, the back side is 2, the side is 3, the 4 is on this side, and the 5, I missed a side, right? 1, 2, 3, 4, 5, and where's my other side? The back side is 2. 1, 2, 3. Other side, side. Oh, up here, 6. And then the flat side is there. So there's 6 sides to a die. So the sample space is 6, a 6-sided dice. And we want the probability of rolling a 4. So there's only one 4. Okay, if the sample has the numbers 1, 2, 3, 4, 5, and 6, and have a cardinality of 6, then how many times as the event, desired event, well, there's only one 4 in the set. So that means a cardinality of the event is 1. So the probability of rolling a 4 is 1 out of 6. So we would want the value of that done with a decimal value. So I'm going to clear my home screen because I got so much stuff on there. And I'm going to do the 1 divided by the 6. And I get this number. Repetition of 6. And so we're going to give it a 3 decimal rounding. So we have an answer of decimal 167. So the probability of rolling a single 6-sided die, and the outcome is 4, is decimal 167. All right. Now how about finding the probability that coin is tossed? The result is tails. Well, our sample space is heads or tails. So there's 2. Now our event is tails. And the cardinality of our event is 1. So the probability of a toss of coin is tails, is the cardinality of our event over the cardinality of our sample space. 1 out of 2. Well, we know that one is a half. And we would put 3 zeros if they said to round to 3 zeros, because it's still a half. Now we're doing rolling a 15 from a 6-sided die. Now this one's important. Understand the scope. Of our sample space. All right. So this one gets your brain wrapped around sometimes the investigation being out of the scope of the sample. So we know that the sample space is finite, like we've all done it all the way through. And we know that the cardinality of our sample space has not changed, 6-sided die. And then we're going to evaluate our event. Well, that means 0 occurrence. There's none. It's an empty set. I miswrote that. Oh, sorry. That means it's either the null set or a set with no elements. So the cardinality of our event is 0. Okay. So now we're writing the probability of rolling a 15. It didn't say 2 rolls to get a 1-5. It said, what is the probability of rolling a 15? So that's 0 over 6. So that is 0. Okay, that was a very good example to let you get familiarized with totally understanding the importance of knowing what the sample space is. So here comes the statistical analysis. Now that we've got the ground rules set up and we understand what's taking place. I'm going to stop right there and start here on the second set. Because I did so much vocabulary, I've talked a lot. So we'll stop there and we'll start up again on the next one.